Hi everyone, this is lesson 9.8, comparing linear, quadratic, and exponential functions. So we're coming to the end of unit 9, and next we'll do statistics. So we've already learned about all three of the types of functions, linear, exponential, and quadratic functions, that you're going to be learning this year. Okay, and the rest of the year will just be statistics and probability and applying and then error testing. So here we want to classify each as linear, quadratic, or exponential. So if there's no, if it's just x into the first power, that would be linear. Linear is x, just x. And then quadratic has an x squared in it. And then exponential is a number to the x power. Or actually we would say a times b to the x. So for this one, this would be linear, because x doesn't have an exponent. B would be exponential because it's 5 to the x. X is in the exponent. This f of x equals 2. There is no x in it, but it's kind of like x to the 0 power. So that would be just 1. So this is actually just a horizontal line. So this is linear. And then 4 times 2 to the x plus 1, exponential. And then here, once again, the x is in the exponent, so this would be exponential again. And then here you've got x to the second power, so this is quadratic. Okay, so we can also write the equation. So for part A, this would be exponential. And remember, the equation is y equals a times b to the x, where a is the y-intercept and b is what you're multiplying by. So here, if you're going from 6 to 2 to 0.75, going from 6, oh no, sorry, this is going from 6 to 3 to 1.5. So you're multiplying by 1/2 here to get from 6 to 2. So the b is 1/2. The a is 3 because that's your y-intercept. So we would write y equals 3 times 1/2 to the x. For part B, this is linear. And let's see, if I pick my y-intercept as 4, and if I go down 4 and over 2 to get to this point, or you could go down 2 and over 1, the slope would be -2. So the equation would be y equals -2x, because negative mx is the slope, and then plus 4. For part C, this is exponential again. So we would do y equals the a. Let's see, you're going from -12 to 6. Is that a 6? Hold on, this is 2, 4, 6, 8. For this one, actually, this isn't exactly on -12. We're not going to be able to figure out the slope for this one, or the equation for this one, just because you guys don't know enough. All right, for part D, this is linear, and it's an x equals equation. Since it's a vertical line, x equals a number that goes through the x-axis, which is 3. For part E, so if it's quadratic, one strategy for writing it in the equation, y equals ax squared plus bx plus c, is to start in vertex form. So y equals a is your slope. So here you're going from 2 to 3. So that means the slope is 1, because to get to the next point over, you just go up 1. So a is 1. And then the vertex is 0, 2. So we would write x minus 0 squared plus 2. Right? And then let's simplify this. So this would just be x squared plus 2. Okay, for this equation, this is linear, so it's y equals mx plus b. So your slope, you're going down 3 over 1. So the slope is -3x, and then plus 1 is the y-intercept. This is a sine curve, so this would be neither, and obviously we don't know how to write the equation for that one. For this one, we can write the equation for this exponential function. So the y-intercept would be, this goes 2, 4, so this is 3. And you're going from 3 to 10, or is that 10? Oh, I'm sorry, that's not 3, that's 5. That's negative 5. So you're going from negative 5 to 10 to negative 20. So negative 5, negative 10, negative 20. So what are we multiplying by? We're multiplying by 2. So the b is 2. So the equation would be y equals negative 5 times 2 to the x. Okay, so you've already done stuff like that before. We're just revisiting it, refreshing our memories. Okay, so for this next table, this next part, you can identify it using a table. So here, quadratic functions have a constant second difference, or we'll start with the linear functions. So linear functions have the same first difference, and that's like the slope. Quadratic functions won't have the same first difference, but they will have the same second difference. And then exponential functions have constant ratios, so you're multiplying by something. Where for linear and quadratic, you want to look for what you're adding or subtracting. So in these examples here, it shows you that the first difference, as long as the x is consistent, then you can compare the y's. And since you're subtracting 1, that means it's linear. Oh, wait a minute. This says quadratic. I'm not sure why this says quadratic. Maybe it's matching. So yeah, I think this is supposed to be matching. So this one is linear. This one is quadratic because although the first difference isn't the same, the second difference is 2. And then this one's exponential. Or just the formatting got off because you're multiplying. All right, so for this one, we're doing 3 plus 3, or minus 3, minus 3, minus 3 for all of these. So since the first difference is the same, this would be linear. Right here, we're multiplying by 2 times 2 times 2, so this would be exponential. And then this one, you're adding 18 plus 18 plus 18, so this is also linear. And then we'll look at a quadratic one. For this one, you're subtracting 3, subtracting 1, adding 1, adding 3. And then the second differences are 2, 2, and 2. So that means that we have a quadratic because the second differences are the same. Oh, I definitely spelled that wrong. Quadratic. Okay. This one you're dividing by 2 and multiplying by 1/2 each time. So that one is exponential. And obviously this one's exponential because it gives you the equation up there. Okay. So the next part gives you just some more examples and a summary. So if it's linear, you can write it as y equals mx plus b, but the slope is the number you add or subtract each time. Y-intercept is the starting amount or y value when x is 0. The quadratic functions, you can either write it in vertex form or you can write it in factored form. So this is factored form. But then you would have to FOIL, multiply your equation out to get it into standard form for your final answer. And then for exponential, y equals a times b to the x, where the a is your y-intercept and b is your constant ratio. All right, so these are just some more examples that I'm going to include in the Edge Elastic for at least these two, because you could be able to do these yourself. Actually, why don't you go ahead and try it now? So for part A, this is linear, and the equation would be y equals The slope is you're going from this point, I'm going to just pick 2 points here. You're going up 3 and over 1, so it would be 3x, and then your y-intercept is -5, so -5. For this one, this is exponential, and the equation would be y equals, the a is your starting point, so 2, and then b is what you're multiplying by. So to get from 2 to 6, you're multiplying by 3. To get from 3 to 18, you multiply by 3 as well, or 6 to 18. So 3 is the b. All right, part C is a little bit different for quadratic because, well, I guess we could do it in vertex form. So there are 2 different ways you could do this, I guess. So the vertex, do we see the vertex here? Let's see. Yes, so this would be the vertex because you see the 8 and the 5 and the 0. You've got symmetry. So your vertex would be 0, 9. And let's see, the slope 1 unit from the vertex, if it goes from 9 to 8, that means that the slope is -1. So then we can write it as y equals -1 times x minus 0 squared plus 9, and simplify this as y equals -x squared plus 9. Okay, you could also write this based off of the zeros. So you could say y equals -1, and then if your zeros are -3 and 3, you would write x plus 3 and x minus 3. If you FOIL this out, you get y equals -x squared, and then the 3x and the -3x cancel, and you get -9. So that becomes the same thing, -x squared plus 9. All right, so the next one, you're adding 3 each time if you look at the table, and your y-intercept is -7. So this is linear, and the equation would be y equals, the slope is 3, so 3x, y-intercept is 7, so -7. Okay, I don't want to do all of these because I want you to practice just some of these in the edge elastic. But if you want to get a head start on the edge elastic, you can certainly try these out, and then tomorrow you can put them in as your answers because they'll be the same thing, as well as additional questions. All right, so that is the end of this lesson. I hope you guys have a great day and a nice weekend.